Hi you guys, today I'm going to talk to you about heating curves, and I'm going to show you how to calculate heating curve equations. So first of all, if you go to your notes, these are the water constants that are given to you. Okay, this is right here where it says specific heat. This is the specific heat of the solid. Okay, so we're talking about water, so this is the specific heat of ice. Okay, right here. Of course, you need to memorize the specific heat of water, liquid water, which is 4.18 joules per gram degrees Celsius. And again, the specific heat of gas, of water, this is the specific heat of gas, which is steam. Okay? Okay. So, and this is 2.01 joules per gram degrees Celsius. So these two values, the specific heat of a solid, which is ice for water, and the specific heat of gas, which is steam for water, these two specific values will be given to you. You do need to memorize the specific heat of liquid water. Okay. Also, you will be given on the test and on the quizzes in class the change in H for fusion. Now, we will be using a different value, which is 333 joules per gram. Okay, so that's the value we will actually use for a change in enthalpy for fusion. Now, for a change in enthalpy for vaporization, the value we will use is 2,260 joules per gram. Okay. Again, these two values will be given to you on the test. You do not need to memorize it. Okay, so let's start on our specific heat, heating curve problems. And let's start with the first example. It says, how much heat would it take to raise the temperature of 1 gram of water from negative 25 degrees Celsius to positive 125 degrees Celsius. And so it says, how much heat will it take? Well, what they're really talking about is they're asking you how much total heat will it take to raise the temperature from negative 25 to positive 125 degrees Celsius. So the very first thing you should always do for any heating curve problem is that you should make a graph, okay, for that. Now, we're already talking about water in this case. So we're going to start with negative 25. Okay, I'm going to put my 0 right here. This will be negative 25. Temperature will go, remember, on the y-axis, and time goes on the x-axis. So keep in mind that water, this is a solid, but water starts melting when it gets to 0 degrees Celsius. So this is where your first plateau is going to come. And keep in mind that your plateau is not too big, it's small because the potential energy and the kinetic energy is not so high right now. Then you're going to move on up, and wherever you decide to stop, go across, and that's your 100 degrees. Keep in mind that's the temperature that water starts to boil. Okay? And of course, notice that this plateau is a lot longer than this, because by the time we get to the second plateau, kinetic energy has increased a lot. And so has potential energy, and it's going to take a lot more energy for the formation, for this formation to be completed, where our substance goes from liquid to finally steam. And so wherever you want to stop, remember this is freehand, it's a sketch, so it doesn't have to be absolutely perfect. So that'll be 125 degrees Celsius. Okay, so this is our heating curve that we're going to do. Always do heating curves on your test, you guys. It's going to help you so much in understanding what is going on. So we're going to label each one of those areas, Q1, Q2, Q3, this is Q4, and Q5. Okay, since we're talking about total heat, what that's going to mean is that we're going to end up adding each one of these heat that we get at each phase of the heating curve. So this will be Q1, Q2, Q3, Q4, Q5, and this is Q total. Okay, so again, Q1, Q2, Q3, Q4, and Q5. So let's start off with Q1. Notice that it's a slant, so that is equal to MCAT because you are changing temperature. So the mass of our substance is 1. The joules that we have, keep in mind that this is the ice phase, so this is the specific heat of our solid, okay, of our solid. And this is, of course, change in T, which is 0. This is TF right here, and this is TI. So it's 0 TF minus TI. But in this case, it's 0 minus negative 25, which is why you have that positive 25. Okay, so you should get something close to this. Next one, we have Q2 happening. This is our first plateau. This is where you get the mass of the substance right here. And there's some extra information. Go ahead and scratch that out. You don't need that at all. So this is actually our mass that you have. And our change in enthalpy for fusion. Remember, we changed our number because this is kilojoules per mole. We really want to use some other units. So we're going to use 333 joules per gram. Those are the units we're interested in. Okay? When you multiply this together, you get this number. The third one is Q equals MCAT again. So this is where we're in the liquid phase now. This is mass. And of course, this is the specific heat of our water, which is our liquid. And then, of course, final minus your initial. Okay, and you would get an answer, 105 joules. And if any time you want to pause this in the video and just put it in your calculator and work it out, by all means do that. And then, of course, we're right here at our second plateau, which is we have our change in enthalpy for vaporization. Remember, we changed our value to 2,260 because we want another unit. We want joules per gram. And then this is our mass, and all this other information you don't need, so go ahead and scratch that out. When you multiply this together, you should get 2,260 joules. And then finally, our last change that we have, last place where heat is changing on our heating curve, is Q5. That is mass times the specific heat of our gas now, which is steam. Because remember, we're past 100, so our water is now becoming steam. And it is, again, final temperature minus your initial temperature. That should give you something close to this, 49.2 joules. Keep in mind, when we're trying to find the total heat, you are going to add up each one of these areas on your curve. So you're going to add up Q1. Let me straighten it out for you. There we go. Q1 plus Q2 plus Q3 plus Q4 plus Q5. And that should give you something close to this. Okay? So, and of course, our Q stands for heat transfer. So about 2,800 joules of energy are actually put into this system. They're being added to the system because this is positive, so it'd be an endothermic reaction. Okay? Let's go on to the second example. Our second example says, how much heat would it require to raise the temperature of 4.50 grams of water from -3 degrees Celsius to 55 degrees Celsius? So in this case, again, we have water. First thing you're always going to do is you're always going to draw your curve. So go ahead and draw your curve for this. We're dealing with water, so we know water will melt and freeze at 0 degrees. Our temperatures are from -3, and that's where we're going to start. So remember, this is freehand. Just going to sketch this. It goes from -3 to positive 55. So we're going to have our first plateau, and then we're just going to go up, but we're just going to 55 in this case. So that's it. And this is our curve now. Okay? This is our curve. So in this case, we have Q1, Q2, and we have Q3. Okay. Now we have three Q values, before we had 5 Q values, you're not always going to have 5 Q values, okay? It just depends on your problem and what you are trying to find. In this case, we are only trying to find how much heat is required. So we're trying to find the total heat is required, so we know it's going to be endothermic. This is a heating curve, okay? So we're going to go from -3 to +55. So again, for each one of these, you're at a slant, that is MCAT. So you're going to solve your problem. Your mass in this case is 4.5 grams. Your specific heat, that is given to you at the very top. This is a specific heat for ice, which is 2.03 joules per gram degrees Celsius. And then our change in temperature in this case is 0 minus -3, which would give us a +3 in this case. When you plug this into the calculator, you should get something similar to 27.4 joules. Our next one that we're looking at is our plateau. It's Q2. Remember, the temperature doesn't change, but this is where the melting phase is coming from. So this is change in H for fusion that we're looking at. Our mass is 4.50 grams, and our change in enthalpy for fusion is 333 joules per gram. Now this is why we want it, because grams will cancel out and you're left with joules. That's why we want to use the same unit. And our answer is 1,503 joules. And finally, you have Q3. This is where our temperature is changing for the last time. So of course that's going to be MCAT, because that's where temperature changes. Our mass is 4.50 grams. Our specific heat is 4.18 joules per gram degrees Celsius. And our change in temperature in this case, our final temperature is 55 minus 0. Okay? And that'd be 1,034.6 joules. We're trying to get the total heat, so we're going to add all this up, and when you do, your Q total in this case would be 2,565.0 joules. Okay, that'll be our answer. Now for the next one, it is how much heat would be released upon cooling a sample of steam at 114 degrees Celsius to water at 11.5 degrees Celsius. Okay, so now look how it is. It's saying that heat is going to be released. So this is not a heating curve. Rather, this is our cooling curve. We're dealing with water again, so we know at 0 degrees, that's when we're going to have our plateau at 0 degrees. And but let's see if that's even needed, because we're going from 114. So I'm going to draw this, 114. And I'm going to go, since we're dealing with water, I'm going to go up to 100. Because what happens to water at 100 degrees? It starts boiling. So that's where our plateau is coming from, okay? And then when we get to, finally, when the steam turns back into liquid, we are now going down further to 11.5 degrees, okay? So in this way, this is a cooling curve where we're starting off really hot, but we're beginning to cool. So heat is being released out of the system, okay? That also means that our change in enthalpy will also be negative, because our energy is decreasing in the system. So this is Q1, Q2, and now this is Q3, okay? So Q1 is, of course, we have temperature change because we're at a slant, and you can see the temperature change. I'm going to pull the graph over. You can see it. So it's MCAT. Our mass in this case, I'm not giving that. I'm going to tell you what it is. It's 25 grams. That's our mass, okay? I'm going to tell you that. So 25 grams. And right here, because we are not, our phase that we are in is steam right here, we're going to be looking at the specific heat of gas or steam. And that value, remember, I gave you at the very beginning. This is where I'm going back to look at my values for water. If it's any other substance on your homework, you can always look it up on the internet. But so this is 2.01 joules per gram degree Celsius. 2.01 joules per gram degree Celsius. And our change in temperature, in this case, our final temperature is 100, and we are starting at 114, okay? So that should give you a negative 703.5 joules, which makes sense because heat, remember, is leaving the system. It's being released. Now for our second one, our second Q value, this is where boiling is occurring, or in this case, it's really where condensation is occurring. Our liquid, our steam is beginning to condense. So it is mass times the change in enthalpy for condensation. Because it's condensation, we're going to say that it's a negative change in H value. Because remember, heat is being released as we do it. So the value that they give you for vaporization, in order to make it for condensation, you're just going to put a negative sign in front of it. So in this case, it is negative 2,260 joules per gram. So grams will cancel out. You're left with joules, and our answer is now negative 56,500 joules. Our last value, Q3 value that we have, that is MCAT again. Okay, so you have 25 grams. And of course, we are now water in this case, so it is 4.18 joules per gram degree Celsius. That, remember, you need to memorize. Our final temperature is 11.5 minus 100, which was our initial temperature. And when you add it up, it comes out to be 9,248.55 joules. You're going to add everything up because, again, we are asking for total heat, total Q value. So our total Q value, when you add everything up, should come out to be negative 66,451.8 joules. That is our value. Okay? That means this is an exothermic reaction. Heat is being released. Okay? Now this next one is saying, would a sample of 30 grams of ice at a temperature of negative 3.5 degrees Celsius melt if 2,055 joules of heat energy are added to it? Provide mathematical proof. So we're going to start this problem off as usual, but they've only given us 2,055 joules. We have to see if that is correct. So we're going to start off, they're talking about ice. I know that means water. So remember, 0 has a big significance. We're going to start off at negative 3.5 degrees Celsius. And then we're just going to stop because it says it just melts. I know that ice melts at 0 degrees, but they don't give us any more information. So we're really just looking for Q1 and Q2 in this case. So Q1 in this case is, again, we're changing temperature. So it is mass, and my mass is 30 grams. The specific heat, remember, is 2.03, and you can always get that from the very top. It's a value that will be given to you. And then change in temperature is 0 minus negative 3, which will be plus 3.5. So give you negative 3.5. And when you add it up, that gives you 213.15 joules. You're going to find Q2 the same way. And this is mass times change in enthalpy for fusion. Our mass is 30 grams. Our change in enthalpy is 333 joules. And when I multiply this, I should get 9,900 joules. So if I add all this up, this is what I have. I get 10,000 203.15 joules. This is how much heat is needed. But I am given the heat, or the Q value, heat given, or that I have, is 2,055 joules. So that means if I take this number, will I have enough heat? No. That means I do not have enough heat to melt the ice. Most of the ice will not melt. And we can see that because we need 10,000, sorry, I hope you can see that. We need 10,203.15 joules, but I only have 2,055 joules. So I don't have enough heat to allow this ice to melt at all. Okay, so that's why most of this ice will not melt at all. Okay, so this concludes our lecture for solving heating curve problems. And remember that you need to memorize the specific heat of water. All the other values will be given to you. Okay, you guys have a good day. Bye.